Once the 3DEP reader has finished its analysis, you'll notice that the Analyze tab pops up with the spectra that it produces. This automatically gets saved as an Excel file, an XML file, and an image file of the image of your graph. So you don't have to do anything with this data right away. You can wait until you're done with all of your analysis and then come back and analyze your data later. So in most cases, this screen will pop up and then you'll just press the Record tab and run your next data point. Once you're at the Analyze stage, you'll load your data, your previously saved data, and then this is where you'll get to fit your spectra. So this is where you can start getting the physiological parameters out of the data that you've collected. In this case, you can set your parameters to fixed in your Tools Preferences section. And in the Defaults section, and in most cases, you'll fix things like cell radius. So these are things that you can measure either before or after your experiments on a hemocytometer using any sort of image analysis, or if you've got a cell counter that does radius measurements for you. You can take those radius measurements and fix it into your model. Other properties that you can set as fixed are your medium conductivity. So this is why those washing steps are so important. Because we make the DEP medium to a set conductivity, such as 10 millisiemens per meter, once you wash all of the supernatant off, all the high conductive media, you'll know that your medium conductivity is that 10 millisiemens per meter. That can get fixed, and also relative medium permittivity can be fixed, and we use the permittivity of water, which is 78. All of your other parameters you can keep as unfixed, and then this is just where you put in your range. So the default range is meant to encompass any physiological values. However, if you know a range that your value should fall within, you can update these ranges. Once you click Save, you can go back to your Analysis tab and then look at individual data sets. So in this case, we're going to look at bands 6 to 9. And like I said before, you normally only need about 10 seconds of analysis. If you're interested in fitting the single shell model, which is your standard DEP model, you'll click on Auto Fit Single Shell Model, and then you'll click Plot. At this point, you'll notice a yellow line come up. So this is our model. You'll notice the R value is 0.9915, so that R value is actually really good. But you can also start to look at your data points and realize that this data point here is most likely an outlier when you look at your model fit. To remove that, you simply click on that point, and it will ask you, do you want to remove this data point? If you click yes, it removes that data point and then updates your R value. So now we've went from 0.9915 to 0.993. So the fit has gotten better removing that data point. You'll also notice that things that got adjusted were cytoplasmic conductivity, cytoplasmic permittivity, specific membrane conductance, specific membrane capacitance. Your medium conductivity and medium permittivity stay consistent, stay fixed, and then the cell radius is whatever you want that to be. Now, if you've got cell radius measurements that vary, so for instance, you've got a large standard deviation, one thing you might want to consider doing is fitting this model with a range of radius values. So in this case, it's 5, but then if we come in here and tell it 4, you can replot that data, and it replots a new model. So it hasn't changed much, so you can kind of verify that that change in radius measurement hasn't done anything to your model. If it does do things to your model, then you may want to consider saving all of those results. Once you're happy with your fit, you'll simply click Save Result, and everything gets automatically saved to whatever that original save folder that you've put into your default path at the beginning of your data analysis. You get an XML file, and you get a graph, so a JPEG file of your data.